Welcome back to Maths with Mrs. Jane. We've talked about probability density functions and what makes a probability density function. We know that it needs to be a function where it is either at the x-axis or above the x-axis for all x values. We also know that the total area between that curve and the x-axis needs to equal 1. What about situations where we have an unbounded domain? All right, so particularly we're talking about situations where maybe we have an asymptote and as x tends towards infinity, your function is tending towards 0, but it's never actually going to touch that x-axis. What do we do in situations like that? Well, what we do is we use our knowledge of limits. Let's have a look at this example here. So we've got a function, f of x is 2e to the negative 2x for x greater than 0 and 0 for x less than or equal to 0. Let's get a little sketch happening of what that's going to look like. Okay, well for x less than or equal to 0, we're just down here. We're on the x-axis. All right, that's sort of trivial that we probably don't even have to draw it really. It's really just this part that we're interested in. When x is greater than 0, we're drawing or trying to get a sketch happening of this function here. When x is 0, this will be e to the 0, which is 1. So this will come here with a y-intercept of 2. And then you need to know your basic shape of your e to the negative x. E to the negative x is going to be coming in towards your x-axis like that. Your x-axis will act as an asymptote. As x tends towards infinity, 2e to the negative 2x will tend towards 0 from above. So in essence, what we need to prove is that this area that has no upper bound equals 1. All right, well, we've got our drawing. That's step 1 done. That's okay. Show that it's a probability distribution function. Well, we've already shown by the graph that it's greater than or equal to 0. So that's okay. Now to do this part here, what we're going to need to do is we're going to need to do a limit. We don't need to consider from 0 down to negative infinity because the function's just 0 there. So really this part from negative infinity to infinity, all we're really concerned with is from 0 to infinity. That's still going to involve us working out a limit. So what it's going to involve is us working out the limit as k tends towards infinity of 0 to k of our function. The part that we're dealing with when x is greater than 0 is this part here. All right, so we're going to integrate and we're going to do the limit. So we're still doing the limit as k tends towards infinity of, integrating this, we're going to get negative e to the negative 2x. So we can sub in an x value of 0, but we can't sub in k as infinity, of course, because infinity is not a number, all right, but we can do a limit. So this will equal the limit as k tends towards infinity of negative e to the negative 2k minus negative e to the 0, which is just 1, okay? What is the limit as k tends towards infinity of this? The limit is 0. All right, and then minus negative is plus, e to the 0 is 1. So we've satisfied our second condition. Question part C, to do probability that x is greater than 1, again, we're going to have to do a limit. So what we're really talking about here is from 1 to infinity of e to the 2e to the negative 2x dx. So again, we're going to do a limit. So we're going to do the limit as x tends towards k from 1 to k of negative e to the negative 2x. So that will be the limit as x tends towards k of negative e to the negative 2k minus negative e to the negative 2. That will be 0, the limit will be 0. We're going to be adding on e to the negative 2, which is 1 over e squared. So I'd probably just leave that as 1 over e squared. If you wanted an approximation, you're welcome to do that on your calculator, but I prefer, to be honest, to leave it as an exact value. If it were a real world situation, a real life situation, then of course you would want to get an approximation for that. But I would probably just leave it like that.